The graphical method is used to solve problems that have only two decision variables. The procedure consists of drawing the equations of the constraints on a coordinate axis x1, x2 to try to identify the area of feasible solutions. The optimal solution of the problem is found in one of the vertices of this area of solutions created, so the minimum or maximum value of the problem will be searched in this data. Next, we are going to show you an example to explain how the graphical method works.
An auditing company specializes in preparing small business statements and audits. They are interested in knowing how many audits and statements they can perform monthly to maximize their income. There are 800 hours of direct work and 320 hours for review. An average audit requires 40 hours of direct work and 10 hours of review. In addition, it brings an income for $300. A tax assessment requires 8 hours of direct work and 5 hours of review. Produces an income of $1,000. The maximum of monthly statements available is 60. The first thing we have to do is set our decision variables. In this case, it will be x1 same number of audits, x2 same amount of settlements. Once we have our decision variables, we establish our objective function. In this case, we want to maximize profits, and we represent it the following way: fx max same 300x1 more 100x2. After this, we will establish our restrictions. In this case, they will be as follows.
Next, we will set the Cartesian as follows. Then we will set the value of x1 from the first constraint to 0 in order to solve for x2. Now we will solve for the value of x1 by equating x2 to 0. To plot R1, we will have as the coordinate the point 0, 100, and 20, 0, and at the time of graphing it will be as follows. Next, we will solve for x2 from the second constraint, setting x1 equal to 0. Now we will equal x2 to 0 to solve for x1. Once we clear x1 and x2 from R2, we will have a coordinate to graph the point 0, 64 and 32, 0. The graphing it will be as follows. Now we will graph the third restriction, as we only have one variable, x2, we will have a constant function.
The optimal solution is always found at one of the vertices of the set of feasible solutions. These values are analyzed in the objective function. At point H, we have the coordinates 0, 60, where 0 is the value of x1 and 60 is the value of x2. When substituting, we will have 300 for 0 plus 100 by 60, and the result will be 6000 from point H. At point E, we have the coordinate 260, where 2 is the value of x1 and 60 is the value of x2. When substituting, we will have 300 by 2 plus 100 by 60, and the result will be 6600. At point F, we have the coordinate 12, 40, where 12 is the value of x1 and 40 is the value of x2. When substituting this in the objective function, we have 300 by 12 plus 100 by 40, and the result will be 7600. At point B, we have the coordinate 20, 0, where 20 is the value of x1 and 0 is the value of x2. When substituting in the objective function, we have 300 by 20 plus 100 by 0, and the result will be 6000. At point G, 0, 0, we have 0 from the values of x1 and x2. If we substitute these values in the objective function, we will have a result 0. The vertex that represents the best value of the objective function will be the optimal solution. In this case, the point that represents the best value is point F, 1240, with 7060 pesos.